Okay, so now I'm looking at the last two parts here. So this again is 2015 11b, but it is the deduce and explain. So deduce whether the dissociation of gas A is exothermic or endothermic. So I'm just going to write in here my A goes to B and C, and I'm going to explain a little bit about this first. If I look at the graph, what's actually happening? As my temperature is increasing, my Kc is also increasing. Remember, Kc is temperature dependent, so it's always going to be constant at constant temperature. So from the graph, I can see that the Kc increases, the temperature increases. Remember, Kc is a measure of how much my reaction produces products. So if my Kc is increasing, that means I'm making more products. Okay, so if I'm making more products, that means equilibrium is shifting to the right. Okay, because the right hand side is my product side here. Okay, that means A is what I start with, so A is disassociating more. Okay, so that means my equilibrium is shifting over to the right hand side. So when I increase my temperature, remember my basic rule is that increasing the temperature always favors my endothermic side. Okay, so if it's favoring my endothermic side, and if I'm having more products being produced, that means my equilibrium is shifting right. So that means my forward reaction is endothermic. Okay? And if you're asked to explain that, that is pretty much what you're saying. Okay? Kc is increasing with temperature. So forward reaction is endothermic. Okay, so that would get you your full marks there. Okay, the second part then is explain how an increase in storage temperature would affect the pressure of the equilibrium mixture. So I've already worked out from the first part here that increasing the temperature is obviously favouring the endothermic side. So because it's favouring that side, I have more products produced. So now what we're looking at is what is going to be the effect on the pressure. And if I again just take my equation as A going into B plus C, I have 2 moles of gas here, whereas I only have 1 mole of gas here. Increasing the temperature, I've already found, brings my equilibrium to the product side. So what we have to look at now is, are B and C under more pressure than A? And if we look, because I have 2 moles of gas on my right hand side, there's more of them, so they're going to be under more pressure. So you're going to have more pressure when you increase the temperature. Okay, the reason why is because I have 2 moles of my gas here in comparison to 1 mole here. So because I have 2 moles here, those 2 moles are under more pressure. So what happens? It increases. And the reason why that happens is because I'm increasing the temperature. So when I'm increasing the temperature, it's favouring this right-hand side, my endothermic side. So that's why I know I've more moles, because I've 2 on the right-hand side. So my pressure is increasing because my reaction is moving towards the product side. Okay, i.e., it's favouring my endothermic reaction when I increase the temperature. Okay, so moving towards products, more products produced, equilibrium shifts right. Okay, so any one of those will get you your marks there. Again, why? because when I increase my temperature, it favours my endothermic side. I've worked out from part 1 that my right hand side is on my endothermic side. If I then compare what I have on my right and what I have on my left, I've 2 moles on my right, I've 1 mole on my left. So this, because it has a greater number of moles, is automatically going to be under more pressure. So the pressure is going to increase because I'm increasing the temperature, so my equilibrium is shifting right.